I'd like to provide you with some background information on the computation of a correlation coefficient and its interpretation. And for that purpose, I pick just a couple of values here in this from this table, just to make it even more manageable. Get rid of the months sold and years sold. And it is key to understand that correlations require knowing the average of the data points and the standard deviation of the data points. So for this subset, we get these numbers for the mean and the standard deviation. We also would like to know at the outset what the correlation between those two variables is for this particular data set. So we get about 0.3 for this subset of the entire data. So at the core of computing a correlation is the notion of computing deviations from the mean. As we did when we computed the standard deviation as a measure for dispersion, we computed deviations from the mean, and then we had to square them and took the average and took the square root, etc. When we computed the standard deviation. Now we're not interested in just the dispersion of a single variable. We would like to see the common dispersion, if you want. So we're looking at deviations from the mean for the living area, and do the same for the sales price. All right, so now we've got pairs of deviations from the mean. Rather than computing or being interested in just deviations from the mean standalone, we're actually interested in the commonalities in deviations from the mean. And for that purpose, we multiply the entries that we've just obtained. And if we would compute the average of these numbers now, this would be called a covariance. So the product of deviations from the mean. And similar to the variance, products of numbers in different units of measurement result in very strange units. So we have living area in square feet and the price in dollars, so we get a number. These products are in dollar square feet, and so similar to the variance, a covariance is not very informative. But we could neutralize the information from the units of measurement and divide that covariance by the product of the two standard deviations. And when we do that, we get a measure that has no dimensions now, and that's the correlation coefficient.